Welcome viewers. In this video we'll see the flip-flop conversion D flip-flop to SR flip-flop. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. Link is given in the description box. Now we'll go to the topic flip-flop conversion D type to SR type. We know that flip-flop is a storage element. It will able to store 1 bit data. The output 2 stages available: present state, next state. The next state output is depends upon the present state as well as the input. Input present state will decide the next state. So that is given here. Qn is the present state, Qn plus 1 next state. So this is the basic about the flip-flop. D flip-flop and SR flip-flop. SR flip-flop, we know S means set the output, set means 1. R means reset, reset means 0. Now we'll see the conversion table. D flip-flop to SR flip-flop. So the D flip-flop going to convert it into SR flip-flop. So first we will see the truth table of the SR flip-flop. What is the nature of the SR flip-flop? S input, R input, the output present state Qn, next state Qn plus 1. So Qn plus 1 based on Qn as well as S and R. So 3 variables will decide the output Qn plus 1. 3 variable mean 8 combinations. Otherwise 0 0, 0 1, 1 0, 1 1. For 0 0 Qn may be 0 1. For 0 1 Qn may be 0 or 1. Like that we have 8 combinations are available. Right. What is the nature of the SR flip-flop? If both S and R is 0, both inputs are 0 means no change in the present state and next state. Present state 0 means next state also 0. Present state 1 means next state also 1. No change. No change in the present state and next state. 0 1. 0 1 is nothing but R. R means reset. Reset means the output is reset. The next state is reset to 0. 0 means 0 is maintained. 1 means 0 is converted into 0. Right? So if the R input is 1, S input is 0 means the output will be reset, that is 0. 1 0. 1 0 means 1 is nothing but S. Set in. Set. So it will set the output as 1. Set means output is 1. 0 means converted into 1. 1 means maintain as it is. If both are 1, S and R values are 1 means it is a invalid, indeterminate. Right? That is not defined in the SR flip-flop. That is defined in the JK flip-flop. Right? So both are 0 means no change in the present state and next state. 0 1 means output is reset. Next state is reset to 0. 1 0 means next state is set to 1. Both are 1 1 means invalid. Right. So this is our requirement. This SR flip-flop. So we need to give the D flip-flop input in such a way that we need to get the status like that 0 0 1 1 0 0 like that. Right. So based on this we need to decide the input of D flip-flop. By giving the proper input to the D flip-flop, the D flip-flop can be converted into SR flip-flop. Right. So that we need a excitation table. What is excitation table for the D flip-flop? From the output we need to decide what is the input. For present state is 0, next state is 0 mean what is the input to the D flip-flop. 0 1 mean what is the input. Truth table means from input we are checking the output. Excitation table means from output we are checking what is the input needed. Right. So this is the excitation table. 0 0 means D input is 0. 0 1 means 1. 1 0 means 0. 1 1 means 1. What is there by excitation table? This D input and next state of output both are same. What we are giving the D input, that will be reflected as the next state, whatever may be the present state. That is the nature of the D flip-flop. The input what we are applied, that is available as the output. Right? So 0 means 0, 1 means 1. Both are same. Whatever may be, it will not bother about present state. Next state is nothing but what the input we applied. So these two are same. So this can be now based on this we can fill these values. 0 0, 0 0 means 0. 0 0 means 0. Right. Then 0 1 means 1. 0 1 means present state 0, next state 1 means we need to give D input is 1. Where it is available? here is it 0 1 means we need to give 1. 1 0 means 0, it is available. 1 0 means 0, right? 0 0 means 0, 0 0 means 0, 0 1 means 1, 1 0 means 0, and another is 1 1. This 1 1 means 1. Here also 1 1 means 1. So from this excitation table we filled the D input. These two are don't care, invalid, so it is taken as don't care condition, X, treated as X, right? I think you are able to understand. If present state 1, next state 0 means D input is 0. This present state 1, next state in 0 means D input is 0. Based on this we filled this value. Now we need to find the logical expression for D input. We need by using the Karnaugh map. Then that can be implemented with the logic gates, with the logic diagram. Now we'll see the K map to find the expression for D input. So this is the K map available. It's a 3 variable K map. The input is S, R and Qn. 2 inputs and present state. That will decide the next state. So the input is S, R, Qn. S is single variable, 2 possibilities. S bar, S, 0, 1. R into R, Qn, 2 variables, 4 possibilities. R bar, Qn bar, 0, 0. R bar, Qn, 0, 1. R, Qn, 1, 1. R, Qn bar, 1, 0. Right? So this 8 column we can fill from the truth table. We know that this is 0, 1, 2, 3, 4, 5, 6, 7. So what is available in the truth table can be filled here. Right. So these 3 are zeros available, these 3 ones available, and these 2 are don't care condition. So there are 2 groups are available. These 4 cells are grouped together and these 2 cells are grouped together. Right. If these 4 cells are grouped together, we have to refer the corresponding second row. Second row is S. What is the column? First column, second column, third column, fourth column. We have to refer. So while referring these 4 columns, all are cancelled. R bar, Qn bar cancelled by R Qn. R bar, Qn cancelled by R Qn bar. All are cancelled. Only this S is available. So while grouping these 2 cells, we have to refer the corresponding first row and second row. S, S bar got cancelled. What is available in the second column is as it is R bar, Qn. Right? So the D input is equal to S plus R bar Qn. So by giving this input to the D flip-flop, that will be converted into the SR flip-flop. Right. Now we'll see the logic diagram. So the logic diagram is available. So this is the D flip-flop that can be converted into SR flip-flop. The D input is a clock input, Qn output, Qn bar complement of output. We need to decide what is the D input. What is the D input? S plus R bar Qn. So this addition is there. So we have one OR gate. One input is S. Another input is R bar Qn. Right. So here in the one more here R bar Qn we need one AND gate. One input is R. After the NOT gate it becomes R bar. Then Qn is connected. Output Qn is connected. So after this AND gate we got R bar Qn, that is added with the S. So S plus R bar Qn given to the D flip-flop input. So that this D flip-flop will be converted into SR flip-flop. Right. Now some description available. We'll see the description. D is the actual input of the flip-flop where S and R are the external inputs. That is given. This is the D input. Normally D is the internal input. S and R is the external input. So that is given here. Then there are 8 possible combinations are obtained from the external input S, R and Qn. We discussed the truth table that we have 8 combinations we obtained. Then since the combination S equal to R equal to 1 is unacceptable, invalid. So that is treated as the D Qn bar taken as don't care condition. We taken as don't care condition, then we executed the truth table. So in this video we discuss how to convert D flip-flop into SR flip-flop. First we discuss the SR flip-flop truth table. Based on that we decided the D input. What is the D input given? From the excitation table of D flip-flop. Then D input logical expression is obtained from the Karnaugh map. That logical expression is implemented with the logic diagram using D flip-flop. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.